Let's take a look at this one. So we'll do the same thing. We'll write out the terms in the sequence. N is starting at 1, so it's minus 1 to the first, minus 1 squared, minus 1 cubed, so on. Simplifying a little bit, this is minus 1 plus 1, and this is minus 1, and then we can kind of see the alternating nature of this sequence. So we'll do the same thing. S sub 1 is the first term. S sub 2 is the sum of the first two. That's 0. S sub 3 is the sum of the first 3. That's negative 1. S sub 4, sum of the first 4. That's 0. Oops, equals 0. Equals 0. All right, and so to find the pattern here, we're going to have to do a little bit of thinking, because looking at, again, the sequence of partial sums, what do we notice, right? So first we have negative numbers every odd term, and then we have 0 every even term. So this is a sequence that's doing different things depending on whether the index is even or odd. And the numbers themselves are always the same, right? All the odd number terms are negative 1. All the even number terms are 0. So that's useful information, right? So if we just start trying to come up with a formula for S sub n, we might want to have, half the sequence be negative 1, half the sequence be 0. How do we do that, right? So one way you might want to try to do that is to build negative 1 to the n into here. That's going to alternate between plus and minus 1. And there are lots of zeros here, right? So plus and minus 1, one way to get it to be 0 is to either add or subtract 1. You can play around with adding or subtracting if you make n something like n plus 1 or n minus 1. So what would this generate right here? So if n equals 1, I would have 1 minus negative 1. So that would be 2. So that doesn't give me negative 1, right? So I want to multiply it by a negative sign. So that would then give me negative 2. And then I want to divide it by 2, because then that would then give me negative 1. So that gives me the first term. Question, does this work for the next term? Let's try it. So S2, right, negative 1 minus negative 1 squared divided by 2. So I get minus 1 minus negative 1 squared, that's 1. Divided by 2, that's 0. So yes, it does work for the second term. So again, this is a trickier example, like I foreshadowed earlier, right? We started simple with the one over here, which is very quick, and now we ratcheted up the complexity. And so we've now found a formula for S of n, so we're technically done with this second example. But I do want to point one thing out, right? As has been the case with earlier videos in this course, with each example, I'm trying to teach you something new. With this example, what I wanted to teach you is trial and error, right? So it's not always going to be so cut and dry and clear as it was in this example, what your S sub n patterns are and how to quantify those patterns to come up with a formula, right? Trial and error is always a good thing to keep in the back of your mind. Try things, right? Like we did, we started off trying this and we said, it doesn't quite work, let's modify it this way. It almost works, let's modify it that way. Okay, that works. Right? So keep trial and error in the back of your mind as a really useful and totally legitimate way to find S of n formulas.